I am Radhakrishna, mathematics teacher. Today we are going to start the new topic, definite integrals. We have already completed indefinite integration and now we are going to start definite integrals. Let us start the session. Fundamental theorem of calculus. If the derivative of a function f of x is capital F of x, then integral a to b capital F of x dx is equal to f of b minus f of a. Or if you write the derivative of f of x as f dash x, then we can write this as integral a to b f dash x dx is equal to f of a minus f of b, f of b minus f of a. Okay. And if you want to understand this result, you take the graph of f of x. This is the graph of y is equal to f of x. This is x axis, origin and y axis. Now take an interval a to b. Suppose this is x is equal to a, this is x is equal to b. You want to integrate f dash x, not f of x. F dash x is nothing but slope of the curve f of x. So integral f dash x between a and b is nothing but the sum of the slopes of the curve f of x in the interval a to b. Okay. Now if you take this interval into, divide this interval into n equal parts like this. Okay. Now let the difference between two vertical lines be h. Okay. This is h. Now if you take the first ordinate and second ordinate, let us draw the diagram separately like this. This is x is equal to a and this is a plus h, and this height is f of a, this height is f of a plus h. Okay. And we know that the definition of f dash x is f dash x is equal to limit h tends to 0 f of x plus h minus f of x by h. This is the definition of derivative. And also by mean value theorem, you know that if a function is differentiable in an interval a to b, then there exists at least one c such that f dash c is equal to f of b minus f of a by b minus a. So in this interval a to a plus h, h is very small. Now there will be an f dash x, slope of this curve, such that f dash x is equal to f of a plus h minus f of a by h, is it not? Now when these two ordinates are very close, then you can take the approximate value of f dash x as f of a plus h minus f of a by h. This h is nothing but dx, the change in x. So cross multiplying by h, you will get f dash x into h is dx, f dash x into dx is equal to f of a plus h minus f of a. Okay. Now, this is f dash x between the first ordinate and second ordinate. If you add all slopes of f dash x, all slopes of the curve between x is equal to and x is equal to b, that means you are adding all values of f dash x in the interval a to b. Adding means that addition is represented by integral. Integral a to b f dash x dx means we have to add all such differences. What is the first difference? F of a plus h minus f of a. Next difference is f of a plus 2h minus f of a plus h. In this way, if you add, the last difference will be f of b minus f of b minus f of b minus h. Now, you can observe that all these terms will cancel out, and what are remaining? F of b minus f of a. So, that is how we get this formula, integral a to b f dash x dx is equal to f of b minus f of a. This is the proof of the fundamental theorem of calculus. Now, suppose the function is discontinuous at the end points. First you will write the indefinite integration. Indefinite integral of capital F of x is small f of x, but we should write constant of integration. If it is without limits, we should write f of x plus c. Now, we take limits a and b and then we substitute. If we substitute, f of b plus c minus f of a plus c. What happens? C cancels. That is why in definite integration we never write constant of integration, that will cancel out. So, the result is f of b minus f of a. So, after integrating, after finding the indefinite integral, we substitute the upper limit and lower limit and take the difference. Now, suppose the function is not defined at x is equal to b or x is equal to a, that does not mean that definite integral is not defined. If f of a or f of b is not defined, then we have to use this formula, we have to take limiting value. Substituting x is equal to b, we are writing f of b, assuming that the function is continuous at x is equal to b. If the function is discontinuous at x is equal to b, we have to write like this, limit as x tends to b from left side minus limit as x tends to a from right side of f of x. Okay. So, we have to understand that every definite integral is nothing but difference of two limits. So, totally it is a limiting value, and also definite integral is a constant, it will not be in terms of the variable, it is a constant, it is a number. Okay. Next, how do you interpret the definite integral geometrically? Now, suppose we are finding integral a to b f of x dx. We are integrating f of x in the interval a to b. This is x is equal to a, x is equal to b. You divide the interval into some equal parts. If you take the first part, first area, we can call it as an elementary strip. So, there are many elementary strips. If you enlarge it, the first elementary strip will be like this. This difference is dx, change in x. Okay. Let dA be the difference in the area. let dA be the difference in the area, small area. This is small area is denoted by dA and small change in x is denoted by dx. Now this area is assuming that this is a straight line because the ordinates are very close. This height is f of x, this is dx. So if you take a rectangle like this, what is the area dA? dA is equal to f of x into dx. F of x into dx. Now integrating on both sides, we get integral dA is equal to integral f of x dx. What is integral dA? It is A. A is equal to integral f of x dx. That means you are integrating f of x dx means you are adding all such elementary areas. Sum of all such elementary areas is going to give you the area bounded by the curve y is equal to f of x and x axis between the lines x is equal to a and x is equal to b. Okay. It is not actually area, it is the sum of the, you can understand it as sum of the values of the function f of x. Integration means sum of the values of the function f of x multiplied by a small change in x dx. Okay. Here the curve is above the x axis. So all values of f of x in this interval are positive and dx is always positive, dx is small change in x. So f of x dx is always positive, f of x is always positive in this interval. So sum of the values of f of x will be positive. So in this case this definite integral is positive and it gives the area bounded by the curve and f of x, curve and x axis in the interval a to b. Now let us take another case. In this case the graph of y is equal to f of x is completely below the x axis. Okay. Here at every point in this interval f of x is negative. Now you are integrating f of x means you are adding all values of f of x multiplied by dx in the interval a to b. Then dx is always positive, f of x is everywhere negative. So if you add all negative values of f of x, then you are going to get this integral as a negative quantity. So in this case the area numerically it may be equal to the area, but this definite integral will be less than 0. So if you want the area you have to take mod. Now let us take another situation. In the first situation we have seen that when the curve is above the x axis definite integral is positive. This is integral a to b f of x dx, it is positive. In the next situation, since the curve is below the x axis this definite integral is negative. Now take the third situation. In this case this is the graph of y is equal to f of x. This line is x is equal to a, this line is x is equal to b. But in this interval the curve is above the x axis at some points and below the x axis at some points. Then what happens if you integrate from a to b? From a to this point the sum of the values of f of x will be negative. So the definite integral will be negative. Again from this point to this point sum of the values of f of x is positive. So the definite integral will be positive. Again it is negative here, positive here. Suppose this small area is say 1 unit, 1 square unit, this area is 3 square units, this area is 2 square units, this area is say 5 square units. Then what will be the value of the integral from a to b? Integral a to b f of x dx is equal to from here to here. If you integrate, the actual area is 1, but you will get negative sign while calculating the integral. So, you will get minus 1, and from here to here the sum of the values is equal to the area, you will get plus 3 because the curve is above the x axis. Again, since the curve is below the x axis, you will get this definite integral as minus 2. Next, you will get plus 5. Then what is the value of this definite integral in this case? 5. Definite integral from a to b f of x dx is equal to 5. So, in this case, this definite integral does not represent the area bounded by the curve and x axis. How to calculate the area bounded by a curve and x axis, we will discuss later in the next chapter, areas under curves. So, in this chapter you have to understand the geometrical meaning of a definite integral. Definite integral is equal to area when the curve is above the x axis, but we have to understand the definite integral is sum of the values of f of x multiplied by a small difference in x dx. Dx is always positive. So, overall you can understand that it is sum of the values of f of x in the interval a to b. Okay. So, when the curve is below the x axis, the definite integral is negative. When the curve is above the x axis, definite integral is positive. Next point, mean value of f of x in the interval a to b. If some numbers a1, a2, a3 and so on an are given, how do you find the mean? Mean means arithmetic mean. Arithmetic mean of these numbers is sum of these numbers by number of numbers. This is arithmetic mean of these numbers. Now, if you take a function f of x in the interval a to b, this is y is equal to f of x, the interval is a to b. Now, the mean value of f of x means average value of f of x in the interval a to b is nothing but sum of the values of f of x by number of values. What is, there are infinite values of f of x in this interval. What is the sum of all the infinite values of f of x? It is given by integral of f of x in the interval a to b. As we have discussed, definite integral is nothing but sum of the values of the function. So, integral a to b f of x dx is sum of all values of the function in the interval a to b divided by number of values will give you the mean value, but number of values is infinite. So, instead of number of values, we take the length of the interval. What is the length of the interval? B minus a. So, this is the mean value or average value of the function in the interval a to b. So, you have to remember that mean value of f of x in the interval a to b is integral a to b f of x dx by b minus a. Okay. Next point, integral a to b f of x dx can be evaluated even if f of x is not defined or discontinuous at finite number of points in the interval a to b. As we have discussed, it is sum of the values of f of x only, but there are infinite values. If we take a function y is equal to f of x and an interval a to b, the sum of all values of f of x in the interval a to b is given by integral a to b f of x dx. Okay. Suppose the function is not defined at some point, at one point it is not defined. That means there is a small hole, negligible hole. then you are missing one ordinate. You are adding infinite number of values of f of x. So, even if one value of f of x is missing, it does not make any difference. The value of integral a to b f of x dx can be calculated, because the different integral is nothing but integral a to b f of x dx is nothing but limiting value. It is the limiting value of this area, means area tends to some number. So, even if one hairline is missing, it makes no difference. So, even if the function is not defined at some finite number of points, this is one point I took, and similarly you can take few more points where function is not defined, but number of such points should be finite. So, this ordinate is missing, this ordinate is missing, this ordinate is missing. When you are adding infinite number of ordinates, even if a finite number of ordinates are missing, there is no problem, we can calculate this integral. Similarly, even if the function is discontinuous at some points in the given interval, suppose in the interval a to b, the graph is like this. This is A, this is B. At this point, say C, function is not defined or discontinuous. Then the value of integral a to b f of x dx is still defined, because you are adding the values of f of x. You will add up to x is equal to c, then from c to x is equal to b. So, the definite integral can be evaluated, but if the function is discontinuous in some interval like this, it is like this and again like this, that means between 2 points from here to here there is no definition of the function in an interval. That means infinite number of values are not defined. In this case, you cannot calculate integral a to b f of x dx. When it is discontinuous at finite number of points or not defined at finite number of points, this can be evaluated, but if it is not defined or discontinuous for some interval, we cannot calculate this integral. See, these are the basic understandings of a different integral. Now, we have seen substitution method, integration by substitution in indefinite integration. If there is integral f dash g of x into g dash x dx, in indefinite integration we will substitute g of x is equal to t. And then we proceed, we calculate. It becomes f dash t into dt. If g of x is equal to t, then g dash x dx is dt. Then we will get integral f dash t dt. What is the integral? F of t plus c. Substituting t is equal to g of x, we will get f of g of x plus c. This is the method followed in indefinite integration. But in definite integrals, if you have suppose limits a to b, while substituting g of x is equal to t, we have to make sure that g of x is a continuous function in the interval a to b, and also as far as possible you make sure that it is a monotonic function, either strictly increasing or strictly decreasing in the interval a to b, otherwise you will be getting wrong answers. Okay. But sometimes you may get correct answers, but sometimes you will get wrong answers. So, to avoid that problem, avoid substituting g of x is equal to t when g of x is discontinuous at some points, or it is not monotonic at some points in the interval a to b. Okay. Now, some basics of definite integrals. Integral a to a f of x dx is 0. Suppose indefinite integral of f of x is some g of x, indefinite integral, then you will substitute the limits. When you substitute the limits, you will get g of a minus g of a, which is equal to 0. So, whatever is the function g of x, the difference is 0. That means, integral of any function between limits a and a will be always 0. Okay. Next point is integral a to b f of x dx can be written as minus integral b to a f of x dx. It is very simple to understand. Suppose indefinite integral of f of x is g of x, then this is g of x between limits a and b. Substituting the limits, you will get g of b minus g of a. But in this case, what you will get? Integral of f of x is g of x. Substituting the limits b and a, you will get g of a minus g of b. Therefore, by taking minus sign, it will be equal to this. Very simple to understand. So, whenever you interchange the limits of the definite integral, the sign will change. Plus becomes minus, minus becomes plus. The next point is integral a to b f of x dx is equal to integral a to b f of t dt. Function is same, limits of the variable are also same. So, it does not matter whether you write x or t for the variable, because suppose integral of f of x is g of x, then you will substitute the limits, then what you will get? G of b minus g of a. If the integral of f of x is g of x, integral of f of t will be g of t. Now, you will replace t by b and a and write the value as g of b minus g of a. So, as long as the function is same, limits of the variable are same, definite integral will be same whether you use x or t. So, this is another basic point of definite integral. Just like the result in limits, limit as x tends to 0, sin x by x is 1. If the question is limit as theta tends to 0, sin theta by theta, it is also 1. Whether you write x or theta or t, function is same, limit of the variable is same. So, final limit will be same. Next is, while calculating the definite integral from a to b, if needed, you can split it into two integrals. Instead of integrating from a to b, integrating from a to b means adding the values of f of x from a to b, we can first add the values from a to c, then from c to b. See, you want to find the definite integral from x is equal to a to x is equal to b. In this case, uniform definition is there, there is no problem, directly you can integrate. But sometimes the function will be defined with some definition up to say c. From c to b it is defined in a different way, it is defined as a different curve like this. Okay. Now at c it is discontinuous, but you want to find the different integral from a to b, then you can't integrate from a to b at a time. So first we have to integrate from a to c. You will find sum of these values by integrating from a to c. Then you will integrate from c to b, sum of these values. Then the sum of the two integrals will be equal to integral a to b f of x dx. In this way we can split this integral into any number of integrals. Okay. We can express it as a sum of any number of integrals. We need not integrate from a to b at a time. Okay. Next, one more point is, you may think that c should lie between a and b for this result, but even if c is not between a and b, this will be correct, because suppose you have selected, this is a to b, you have selected c somewhere here. First you are integrating from a to c, means you will get this area, sum of these values, that means you got some part extra. Then you are integrating from c to b. You can write integral c to b f of x dx as minus integral b to c f of x dx, is it not, from this property. What is integral b to c f of x dx? It is this area. Then you are subtracting this area from the total area, then you are getting the final area. So this result will be true even if c is not between a and b. Okay. Now let us start problems on these basics of different integrals discussed today. In this chapter, in the first class, we will directly follow indefinite integration methods. We integrate, then substitute the limits, that is all. Okay. Integral 0 to 1 tan inverse x. How to integrate tan inverse x? You know that in indefinite integrals there is no direct formula for integral of tan inverse x. We have to integrate it by parts. Take tan inverse x as first function and 1 as second function. Integrate it by parts. First function into integral of the second, that is tan inverse x into x minus integral of derivative of the first function into integral of the second function. Derivative of the first function is 1 by 1 plus x square into integral of the second function is x. So you will get x by 1 plus x square dx. But when there are limits 0 to 1, we have to write limits 0 to 1 like this for first part, and for this integral also we have to write the limits 0 to 1. Now here you substitute the limits. First 1, you will get 1 into tan inverse 1 minus 0 into tan inverse 0, 0 minus, how to integrate this, x by 1 plus x square, derivative of 1 plus x square is 2x. So if you multiply and divide by 2, it becomes f dash x by fx, its integral is log f of x. So it is minus half into, its indefinite integral is log 1 plus x square between limits 0 and 1. And what is the value of this? Tan inverse 1 is pi by 4, pi by 4 minus 0, pi by 4 minus, substitute the limits here, half into Substituting 1, you will get ln 2. Substituting 0, ln of 1 plus 0 means ln 1 or log 1, which is 0. So, final answer is pi by 4 minus half ln 2. Next question. Integral 0 to 1 log x to the base e. Log x to the base e. For log x also we do not have a formula in indifferent integration. We have to integrate it by parts. So, take second function as 1 and integrate by parts. First function, I will write this log x as ln x because base is e. First function into integral of the second function is x minus integral derivative of the first function, derivative of ln x is 1 by x into integral of the second function is x dx. We have to write limits here 0 to 1, 0 to 1. If you substitute 1, 1 ln 1 is 0, log 1 is 0, minus if you substitute 0, 0 into log 0 is not defined. See, the graph of log x will be like this. This is origin, this is x axis, this is y axis. This is the graph of log x. At x is equal to 0 or at x is equal to some negative number, logarithm is not defined. So, we have to take the limit of log x log x at 0. Limit as x tends to 0 plus, because the interval is 0 to 1, x cannot be below 0. So, we have to take limit x tends to 0 plus x ln x in the case of lower limit, minus here what is the integral of this, x cancels, integral 1 is x, write the limit 0 to 1. What is this limit? 1 only. Now, how to calculate this limit? It is limit as x tends to 0 plus x ln x minus 1. Substituting 0 plus, it is 0 plus into log 0 plus. If you observe the graph, when x is just greater than 0, log x is tending to minus infinity. So, this is 0 into minus infinity. 0 into minus infinity is neither 0 nor infinity. It is called indeterminate form. How to calculate the limit now? We have to convert this into 0 by 0 form or infinity by infinity form, then apply L'Hospital's rule. Actually, this is 0 plus. If you write 0 plus in the denominator as 1 by 0 plus, what happens? It becomes minus infinity by plus infinity, where you can apply L'Hospital's rule. So, I will write this x as 1 by x in the denominator. Ln x by 1 by x minus 1. Now, it is minus infinity by infinity. You can apply L'Hospital's rule. What is L'Hospital's rule? You can differentiate numerator and denominator separately, the limit remains same. So, limit as x tends to 0 plus derivative of ln x is 1 by x, by derivative of 1 by x is minus 1 by x square minus 1. Then simplifying it, you will get limit as x tends to 0 plus minus x. when x is approaching 0, minus x will be approaching 0. Okay. So, this limit is 0, 0 minus 1 is 0, minus 1. while writing the final limit we will not write 0 plus or 0 minus, we will write 0. Okay. It may be actually approaching 0 from left side or right side, but final limit should be exactly one number. So finally we got this definite integral as minus 1. Next question, integral minus 2 to 1, minus 1 to 2, integral part of x dx. We know that integral part of x is discontinuous at every integer. Okay. Its definition changes at every integer. If you see the graph of integral part of x, between when x lies between minus 2 and minus 1, integral part of x will be minus 2. Integral part of x will be minus 2, its graph will be like this, a line segment parallel to x axis. When x lies between minus 1 and 0, integral part of x will be minus 1. When x lies between 0 and 1, integral part of x is 0. When x lies between 1 and 2, integral part of x is 1. When x lies between 2 and 3, integral part of x is 2. This is the graph of integral part of x. So we cannot integrate at a time, we have to split this into some integrals. We have to break this integral at every integral value of x, because definition changes. Now first we will integrate minus 1 to 0, minus 1 to 0. Minus 1 to 0, then we will integrate from 0 to 1, then from 1 to 2. In this interval, write first step x dx, 0 to 1 integral part of x dx, 1 to 2 integral part of x dx. So breaking this integral into 3 integrals like this, minus 1 to 0, 0 to 1, 1 to 2. Now in this whole interval, integral part of x is a constant, how much? Minus 1. Integral minus 1 to 0, minus 1 dx. Now in the interval 0 to 1, integral part of x is 0, it coincides with x axis. So write 0, plus integral 1 to 2, in this interval integral part of x is equal to 1, constant, 1 dx. Now what is this integral? Integral of minus 1 is minus x, substitute the limits, minus 1 to 0, plus integral of 0 is constant, 0 to 1, plus integral of 1 is x between limits 1 and 2. Then what will you get? This will be 0 minus of minus 1, 0 minus of, substitute the upper limit, lower limit, it becomes 1, minus 1, and this is 0, c minus c, and this is 2 minus 1. So finally you are getting the definite integral as 0. Okay. But instead of calculating in this way, we can also calculate in a simple way. You know that the meaning of definite integral is summation of the values of the function, it is sometimes area of under the curve. Here you are integrating from minus 1 to 2 means you are adding the values of step x from minus 1 to 2. Okay. Now you can see that this area is how much? this is 1 square unit, this is 1 unit, this is 1 unit. So, totally this area is 1 square unit. But since the area is below the x axis, since the curve is below the x axis, definite integral from -1 to 0 will be negative. So, this area will be, this definite integral, not area, this definite integral will be -1. In the interval 0 to 1, no area is bounded, that is why area is 0 in this interval. In this interval, the area is 1 square unit, curve is above the x axis. So, the definite integral will be 1. So, this definite integral is -1 plus 0 plus 1, finally you will get the answer 0. Okay. Now, let us proceed to the next question. Integral -2 to 3 x e power x square dx. Okay. Without limits, what will you do? You will substitute x square is equal to t, because derivative of x square is 2x, x is there. But here in the interval -2 to 3, x square is not monotonic. In the interval -2 to 3, the graph of x square is this graph of x square. It is not monotonic, decreasing from -2 to 0, increasing in the interval 0 to 3. So, it is not advisable to substitute x square is equal to t. So, what we do? We split this into two integrals, -2 to 3 x e power x square, sorry, -2 to 0 dx plus 0 to 3 x e power x square dx. Now, in the interval -2 to 0, it is strictly decreasing, x square is monotonic. 0 to 3 also it is monotonic. So, we can substitute x square is equal to t. Now, differentiating on both sides, you will get 2x dx is equal to dt. X dx is dt by 2. So, and what will be the new limits? One important thing is, whenever you substitute some function as t, we have to write the limits of t only, not limits of x. So, what to do? We have to change the limits. When the variable is x, we have to write the limits of x. When we are changing the variable to t, we have to write the limits of t. What is the lower limit of x? -2. If x is equal to -2, what is the value of t? T is -2 whole square, 4. If x is equal to 0, what is the limit of t? 0 square 0. So, here the new limits are 4 to 0. What is this function? E power t into dt by 2 plus, coming to second integral, we have to change the limits. When x is 0, t is 0. When x is 3, what is the value of t? 9. So, here we have to change the limits as 0 to 9. This is e power t into x dx is dt by 2. Now, I will take 1 by 2 common, 1 by 2 into integral e power t is e power t. We have to substitute the limits 4 and 0. Here e power, integral of e power t is e power t, substitute the limits 0 to 9, then what will you get? Half into substituting 0, you will get 1 minus c power 4. plus substituting 9, you will get e power 9, substituting t is equal to 9 minus e power 0 1. So, finally, 1 cancels, you will get the answer as e power 9 minus e power 4 by 2. If you directly substitute x square is equal to t, what will you get? Let us see. If you directly substitute x square is equal to t, limits will be 4 to 9, you will get e power t dt by 2. So, you will get half into e power t 4 to 9. So, you are getting e power 9 minus e power 4 by 2, you are getting the same answer. In this example, the answer is same. Now, let us take another example. I will take integral 0 to pi dx by 1 plus 2 sin square x. If you want to find this without limits, first you tell the method. When the integral is in the form of 1 by a plus b sin square x or 1 by a plus b cos square x, what is the method? We have to multiply and divide by secant square x. Integral 0 to pi secant square x dx by secant square x plus 2 tan square x. Okay. Now, we can write this as integral 0 to pi secant square x dx by 1 plus 3 tan square x. Now, let us substitute tan x is equal to t, because derivative of tan x is secant square x, it is present in the numerator. So, in indefinite integration, how will you integrate? You will put tan x is equal to t. Now, let us proceed. Put tan x is equal to t. Its derivative is secant square x dx is equal to dt. Then, what will be the integral? Integral dt by 1 plus 3t square. And what are the limits? If x is equal to 0, then t is equal to tan 0, 0. If x is equal to pi, then what is the value of t? Again 0, tan pi is 0. So, the limits of t are 0 to 0 dt by 1 plus 3t square. What is integral 0 to 0 dt by 1 plus 3t square? 0. When the upper limit is equal to lower limit, integral is 0. But how can it be 0? When you integrate a positive function. See, observe 1 by 1 plus 2 sin square x is absolutely positive. So, its graph will be strictly above the x axis. So, if you integrate, you must get a positive number without doubt, but you got 0. So, definitely this is wrong answer. It is because tan x is not a monotonic function in the interval 0 to pi. In the interval 0 to pi by 2, the graph of tan x will be like this. From pi by 2 to pi, the graph will be like this. So, if you consider the interval 0 to pi, tan x is not monotonic. It is discontinuous and not defined at pi by 2. So, that is why we are getting the wrong answer. So, please avoid substituting a non-monotonic function as t. Next question. Integral 0 to pi by 2 dx by a square cos square x plus b square sin square x. Here, what is the method in indefinite integration? We will multiply and divide by secant square x. you will get secant square x dx by denominator becomes a square plus b square into tan square x. What will you substitute? Tan x is equal to t, and in the interval 0 to pi by 2 tan x is monotonic. So, the substitution is 100% correct. Put tan x is equal to t, then you will get secant square x dx is equal to dt, and we have to find new limits now. If x is equal to 0, then x is equal to 0 implies t is equal to tan 0, 0. If x is equal to pi by 2, t is not defined, upper limit is not defined, but we have to understand that these two are limits. So, strictly speaking, we have to write when x tends to 0, then t tends to 0. So, in the case of upper limit, x tends to pi by 2, then t tends to what? But here we have to take x tends to pi by 2 from left side. When x tends to pi by 2 from left side, what is the limit of tan pi by 2 minus? You can see from the graph, it is plus infinity. So, this will be lower limit is 0, upper limit is infinity. Integral 0 to infinity dt by a square plus b square t square. What is the integral now? Assuming that bt is some x, it is in the form of 1 by a square plus x square. Integral 1 by a square plus x square is 1 by a tan inverse x by a. Tan inverse x by a means bt by a. Then we have to divide by derivative of inner derivative of bt, that is b. Now take limits 0 to infinity, because 1 by ab is constant, I wrote it outside. Now substituting infinity, what is tan inverse infinity? It is pi by 2 again, pi by 2 minus tan inverse 0 tends to 0. Here tan inverse infinity tends to pi by 2, we are writing the limit only. So, finally, we get the answer pi by 2ab. Okay. Next question. Integral alpha to beta root over x minus alpha by root beta minus x. There are three questions in this model. One is root x minus alpha by beta minus x, another is root over x minus alpha into beta minus x, another is 1 by root x minus alpha into beta minus x. Integrals. For these three integrals, there is a standard substitution. All of you remember, the substitution is put x is equal to alpha cos square theta plus beta sin square theta. It is the standard substitution for these three models. Now let us solve this by using that substitution. Differentiating on both sides, we get dx is equal to, what is the derivative of alpha cos square theta? Alpha into derivative of cos square theta is 2 cos theta into minus sin theta, that is minus sin 2 theta, plus beta into derivative of sin square theta is 2 sin theta cos theta, that is beta into sin 2 theta into d theta. Now taking sin 2 theta common, it will be beta minus alpha into sin 2 theta d theta. Now we have to calculate new limits. If x is equal to alpha, then alpha is equal to alpha cos square theta plus beta sin square theta. Take all the terms to left hand side, you will get alpha into 1 minus cos square theta sin square theta minus beta sin square theta is equal to 0. Taking sin square theta common, alpha minus beta into sin square theta is equal to 0. But alpha and beta are distinct. In the question you also add one condition, alpha is less than beta. Okay. Then and that is obvious because here alpha is less than beta, otherwise what happens, x minus alpha into by beta minus x should be positive. X minus alpha into beta minus x should be positive. That means x minus alpha into x minus beta should be negative, then x lies between alpha and beta. Okay. So one of them should be smaller, I am assuming that alpha is smaller. Now since alpha is not equal to beta, sin theta must be 0, then theta is equal to 0. Okay. Now let us substitute the upper limit, x is equal to beta. If we proceed in the same way, we will get theta is equal to pi by 2. Then this will be integral 0 to pi by 2 root over x minus alpha means alpha cos square theta plus beta sin square theta minus alpha by beta minus x, beta minus alpha cos square theta minus beta sin square theta into dx is beta minus alpha into sin 2 theta. If we simplify this, you will get sin theta by cos theta. The calculation work you check, into beta minus alpha. I can write beta minus alpha outside the integral, into sin 2 theta is 2 sin theta cos theta. What happens? Cos theta cancels, remaining will be 2 sin square theta. So it will be beta minus alpha into 2 sin square theta can be written as 1 minus cos 2 theta. Okay. Now if you integrate, you will get pi by 2 into, integrate and substitute the limits, you will get pi by 2 into beta minus alpha as the final answer. The calculation part you complete. Similarly for these two, we can follow the same substitution. Okay. This question you substitute x is equal to a cos square theta plus b sin square theta and find it. Okay, the time is up for today. We will continue in the next class.